This is Richard C. I'm answering a question from calculus submitted by a student, and this has got a lot going on. So we're going to start by finding dy dx, which I'm going to, instead of using dy dx, I'm just going to use y prime. Hopefully that's not going to confuse anyone. I don't see why it should. Just because the work is easier this way. And let me get started now. Okay, so we have x squared y plus y squared x equals 6. And basically we want to find y prime, which is dy dx. So we're going to use the product rule here, first times the derivative of the second. So it'd be x squared y prime plus the second, which is y, times the derivative of the first. So it's going to be 2xy. Okay, so that's just product rule for the first term. First times the derivative of the second plus the second times the derivative of the first. And we're going to do the same for the second term here. First times the derivative of the second is going to give us y squared. Second times the derivative of the first is going to be 2xy y prime. Okay, because the first times the derivative of the second is y squared times 1. The second times the derivative of the first is x times 2xy y prime. The derivative of 6 is 0. So this is called implicit differentiation. So we're going to combine our terms here that involve y prime. You're going to get x squared plus 2xy times y prime, and then 2xy plus y squared, because they don't involve y prime, equals 0. Now we're going to move everything over and solve for y prime. So you move this term over, you're going to get negative 2xy minus y squared over this should be x squared plus 2xy. Okay, so now we're in position. This is, let me label these A, B, and C here. So we found the answer for part A right here. Now we want the equation of the tangent line where x is 2 and y is 1. We'll start by finding the slope. So we're just going to plug 2, 1 into the expression for the first derivative, which is the slope. And so it's going to be negative 2 times 2 times 1 minus 1 squared all over 1 squared plus 2 times 1 times 2. So this is going to give us negative 4 minus 1 over, let's see, oh, that's not a 1 squared, that's a 2 squared. X is 2 here, so it's a 2 squared, my apologies. So that's 4 plus 4 here. Equals negative 5 over 8. And now we're going to use the point slope form of the equation to find the equation. So it's going to be, because I'm using this point, it's y minus 1 is equal to negative 5/8 times x minus 2. And that's our answer to part B. And now the last part, C here, which would be find the coordinates where the curve has a horizontal tangent line. Well, that means that y prime would be 0. If we look at the expression of y prime, here it is. The only way for this thing to be 0 is when the numerator is 0. So we're going to set that to 0. So you're going to get, let's see, when we set that to 0, we're going to get y squared. Let's see, I'm trying to find my work here. Yeah. What I did, I found it now, sorry. Just want to make sure I'm following my notes. So I'm going to factor out the y, and I'm going to ignore the negative. So it's y, or if you want negative y, times 2x plus 1 equals 0. That gives us two answers. Either y is equal to 0, or x is equal to negative 1/2. And so obviously we want the situation when x is equal to, well, let's see, what did I do here? That's a y here. That's a y squared. Yeah, that's a y. So we're not so lucky with this other piece here, because it's an equation. So y equals, y would have to equal negative 2x. Now we can't use this solution y equals 0 because you can see from the original, if y is 0, then you have 0 equals 6. So this curve is never going to go through y equals 0. And then if we look at negative 2x, we can deal with that and plug that in. So I'm going to plug negative 2x into this equation here. So you're going to get x squared times negative 2x plus 4x squared times x is equal to 6. And this is going to give me negative 2x cubed plus 4x cubed equals 6. And that's going to give me 2x cubed equals 6. So x would be the cube root of 3. Now to get the y coordinate, I have to plug the cube root of 3 into this equation. And I'm not going to take up time with that. You end up with negative 2 cube root of 3. Okay, and that's part C. Now I really think you're going to be a lot happier if you can see a graph. So I'm going to import a graph that represents what's going on with this problem. And I did this in Desmos. Highly recommend that you work with graphs when you're done, not when you're working the problem. You need to be able to solve the problem by hand first. And then, so the red portion is the original function. And so it's got these three arms here. And we can't really check part A here, but when we want to know the slope at at 2 comma 1, you can see this is 2 comma 1 here, and I got a slope of negative 5/8. And then this blue line is this line here that we're showing here exactly. And you can see that it's tangent to the original function, which is in red. You can see it's tangent there at 2 comma 1. And so that line looks correct. And then lastly, the coordinates where the curve is horizontal. Well, the curve is horizontal somewhere around in here, in this neighborhood here. And the cube root of 3 is 1.4 roughly, and you can see that this is roughly 1.4 in here. And then negative 2 root 3 would be roughly negative 2.9. I'm just going to put the decimal equivalent here. So it's roughly 1.4 comma negative 2.9 in decimal. And you can see this is roughly negative 3 for the y value and roughly 1.4 for the x value. So everything that we did in part C looks like it's right based on the curve. If we were in the live version of Desmos, we could actually calculate this, and I can show that to you, but I'm not going to get into all that. I think it's just good to look at the graph as a sanity check, just to make sure that what we're working on, makes sense visually, graphically. So that's the way to do this. It's a fair amount of work, but it's very good practice. This is called implicit differentiation for part A, and that's the heart of the problem. And then the rest of it is just sort of arithmetic, not very challenging, but easy to make a mistake. So that's the answer for this question. I hope my answer here helped you, and I'll see you again next time. Bye-bye.